Hello, class. In this video, I'm going to continue to answer Test 2 review questions for Math 145. I'd like to start on question number 13. It looks like there's a 13A, B, C, and D. I'm only going to answer question 13A and 13B. All of the problems are solved in a similar fashion. It wants us to solve the equations for x algebraically and graphically. All right, so algebraically really means seeing if we can kind of manipulate what we were given, right? So if I have 5 to the x, is there a way to write 625 with a base of 5? And think about it. I think 5 raised to the 4, if you do 5 times 5 is 25, 25 times 5 is 125, and 125 times 5 is 625, right? So what value of x do we need to get this? It would be x equals 4. So the answer here is x equals 4, right? But if you didn't see that, I would just suggest graphing both sides of the equal sign, okay? So, for example, the left side is 5 raised to the x. So I clear all this out. Also, make sure your plot 1 is not highlighted, right? When we were doing scatter plots before, we highlighted this plot 1. So we want to take that black box off by hitting the up arrow, pressing enter, and then the down arrow. Okay, so the left side of the equal sign is 5 to the x. So 5 raised to the x. And the right side of the equal sign is 625. And when I think about a window, I'm going to have a straight line at 625. So I'm going to go from 0 to 10 for x min and x max. And for y min, I'll start at 0, and I'll put some number bigger than 625. I'll put in 700. Then I'll press graph. And the intersection is our answer, right? And by the way, we already know the answer, right? The answer is 4. But if we didn't know, right, act surprised when we get the answer, like if you didn't know. Second, trace, number 5 for intersection. First curve, I press enter. Second curve, right, that's the red line, I press enter. Guess where do you think the answer is? I press enter. And it gives me the exact point, right, at 4, 625, right? Intersections 4, 625. So what value of x will give me 625? The answer is 4, right? And if you're doing this on a test on campus and your method is graphing, you actually have to sketch the graph, 4, 625, maybe give me an x and a y, and then you would say final answer x equals 4, put a box around it. Okay, so that's how you would do all of these problems, really. Just graph both sides of the equation, get the intersection. Let's do one more, letter B. I'm going to clear my screen first. So let's take a look at number 13. All right, so again, algebraically, 4 to the x equals, instead of writing 0.25, I'm going to write 1 over 4, because isn't 1 over 4 the same as 0.25, right? 1/4, 1/4. All right, so what value of x would make this true? Well, we know that 4 to the 1 equals 4, so 4 to the negative 1 equals 1 over 4, right? So the answer should be x equals negative 1. Now, if you didn't like the algebra, you didn't see the algebra, it wasn't obvious to you, again, you can always get out of a jam by graphing the left side and the right side of your equation. So I press y equals. The left side of my equation is 4 to the x. Right, 4 to the x. The right side of my equation is 0.25, right? 4 to the x, 0.25. But my window's tricky. I'm going to have a straight line at 0.25, right? Think about that. Right, again, we already know the answer is negative 1. Whoops. Right, so when we're graphing this, we're going to have a straight line. If this is 1, 2, 3, right? 1, 2, 3. The right side of my equation is 0.25, so I'm going to have a straight line at 0.25. I didn't really draw that very well, but, right? So we're trying to figure out when is this going to intersect, okay? All right, so my window's got to be really tight. So I did, for my window, I went from negative 5 to 5, right, from the left side to the right side, and negative 5 to the 5 on the y-axis, I press graph, and let's see where this thing, oh, actually, we know what the answer. The answer should be -1, I believe. Right? Again, it's a really tight window. You can see it's really tight. But let's go through the motions. Second, trace, number 5, enter, 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 and what do you know? X equals -1, y is 0.25. X equals -1, y is 0.25. Right, so again, you would sketch some type of graph. It wouldn't be pretty. Right, so you have something that does, I don't know, something like this. Oof. Right, again, this doesn't have to be a Picasso. But that's my graphic solution. Okay, so that's number 13. Let's go to number 14 in a moment, but I want to clean up my board first. Okay, so let's take a look at number 14. Local college, let's see. They give us a function that models the enrollment. All right, so we can see what happens to the student population as the number of years increase. Looks like the base year is 1994. Is this function increasing or decreasing? Explain how you know. Well, remember, when we have a function y equals ab to the x, right? If b is bigger than 1, it's growth. If b is between 0 and 1, it's decay. So this 0.95 is between 0 and 1, so we know that this is decreasing. All right, so I said it's decreasing because our value for b is in between 0 and 1. And again, our value for b is this 0.95. Okay? Find the vertical intercept. So you know when we have y equals ab to the x, the a is your vertical intercept. So in this case, the a is the 12.4. So a lot of times people like you to write that as an ordered pair. So I might write something like 0, comma, I think it was 12.4. And the practical meaning, the initial enrollment in, what was it, 1994 was 12,400 students. Okay, let's move this out of the way. Right, so yeah, 0, 12.4 is the vertical intercept or the y-intercept, and that's the initial enrollment back in 1994. Okay, determine the growth or decay rate. All right, be careful. There's a difference between rate and factor. Right, so we have this formula b equals 1 plus r. That's for growth, and for decay, we use the formula b equals 1 minus r. Okay, so remember, the b was given to us at 0.95 equals 1 minus r. So we have to solve this for r, which is the rate. So I subtract 1 from both sides. I get negative 0.05. Let's write that a little neater. Equals negative r. So I can multiply, divide both sides by -1 to get 0.05 equals r. And as a percent, you move the decimal twice to get 5%. So the decay rate is 5%, all right? And the practical meaning, it looks like enrollment will fall by 5% each year. And I spelled enrollment wrong. There we go. Right, so the decay rate is 5%. The enrollment will fall by 5% each year. Okay, let's keep going. No, letter D, it says, what is the enrollment in 2000? So remember, our base year is 1994. So 2000 corresponds to t equals 6, right? So I have to sub a 6 into my original equation. All right, so for letter D, let me write this out. right? So I wrote the equation down here. And again, it's coming from this equation, right? I just rewrote it, but I substitute the value t equals 6, right? So when I plug that into my calculator, 12.4 times 0.95 raised to the 6, I get 9.11, okay? So let's call that 9.12, right? Because we'll round to 2 decimal places. Okay, so let's just write that in there. That equals 9.12. And then we have to kind of interpret what does this exactly mean? So we'd say in the year 2000, or 6 years after 1994, the enrollment was 9.12. But remember, that's in thousands, so it's really 9,120 students. Okay. And then the last piece, letter E. What year will the enrollment first dip below 7,500? Right. So again, we're gonna now substitute 7,500 into S. Oops. Into S, and we're gonna solve for time. Okay. So again, just to be clear, this time they're giving us S. It's the enrollment, but we don't know the time or the number of years after 1994. So I rewrite the equation down here. Let's see, letter E. So this is the equation you'd have to solve for x. So you could graph both sides and get the intersection to get the answer. But the review sheet does say use a table to get your answer. Again, I'd prefer to just graph y1 is this, and y2 is the right side of the equal sign, and then get the intersection. But it does say use a table. So what we'll do is we'll put in our equation into y1, right, the 12.4 times 0.95 raised to the x. The x is what we're trying to find. We want to know what value of x will give us a value of 7.5, because remember, this is in thousands, right? So 7,500 is equal to 7.5 in thousands, right? So we have to set up our table. So if I press second in window, I can tell my table to start at 0 and count by ones. Okay. Now above graph it says table. So right above window it says table set. Above window it says table. So I press second and graph. And now I have to scroll down to see what value of x makes my y 7.5. So it looks like the answer is somewhere between 9 and 10, right? Year 9 and year 10. So I would probably write my table like this, 3 rows. All right, so let me write this down. Something like this. So I kind of created my table over here, right? And these values came from my calculator, right? 9, 10, 11, and these are the values, 7.8, 7.4. So the answer, 7.5, happens somewhere in between year 9 and year 10, right? So if we say year 10 corresponds to 2004, right? Because the base year was this 1994. So 10 years after 1994 is 2004. So you would say in 2004. Okay. So I'm going to stop here, and I will make a few more videos to finish up this review packet. Looks like we only have maybe 1 or 2 more pages to go. Okay. Thank you for watching.